Hello, this is Nathan Seidel, founder of SparkFun Electronics, with a new product release that is near and dear to my heart. Today I'd like to take you on a little bit of a history through some products that we have had at SparkFun for a very long time. The first being the original BlueSMiRF, released in 2007. This product made it so that you could easily connect a laptop or a cell phone over Bluetooth to your Arduino or your project or whatever you had. We had that product for about 7 years until 2014 when the module was retired and we found a new module from a new company. And so this is the BlueSMiRF or Bluetooth Mate, the replacement for that, released in 2014, that proceeded until 2021. So we had about 14 years of BlueSMiRF goodness where it was very easy to transmit serial over Bluetooth. In 2021, this module was retired and a little bit of my heart died whenever BlueSMiRF went away. Well, here today, I'm proud to announce the reboot of BlueSMiRF v2. This is the newest generation of BlueSMiRF that has a whole bunch of fun features packed into it that I'd like to share with you today. So at the core of BlueSMiRF is a new module from Espressif. It's the ESP32 Pico Mini, which is a tiny little module that's got a ton of flash and RAM built into it. It's got Bluetooth, it's got Wi-Fi. It's just incredible. But you don't need to know any of that. What BlueSMiRF does is it makes it really easy to move serial from point A to point B. For the first demo today, we're going to demonstrate how to connect either a desktop, a laptop, or a phone to a BlueSMiRF. In this case, I've got the BlueSMiRF connected over a USB to serial IC, and then we've got two terminals so we can sort of see what's going on. The first thing I'd like to demonstrate about BlueSMiRF is the easy-to-use AT command set. So when we first boot this up, we see BlueSMiRF 1.0. And then if we send it the $3 signs, we get the AT command set. So now we're in command mode, and we can list all the AT commands and see what their various settings are. We can write those to flash, we can reset the radio, we can do all the things we need to do using simple serial commands. Here we are connected to BlueSMiRF. It's ready to go. Now from the laptop, let's open up a new serial port over Bluetooth to that device. Now we are connected to the BlueSMiRF. We should see a constant status green LED indicating that we have a link. Now we can just say fun stuff like hello world. So from the laptop, we are sending hello world over to the BlueSMiRF, and we can see that in the terminal window. And similarly, we can send things to the laptop. So good night, moon, and we have serial moving back and forth. For demonstrations today, I'd like to show you the two-way communication. So in this case, I have the first 5 chapters of Moby Dick that we're going to send from the terminal to the BlueSMiRF, and similarly, we're going to send it back to the laptop at the same time. What this demonstrates is sort of that duplex nature of Bluetooth. We can send data in both directions at very high speeds, and because of the Bluetooth stack, that data gets there byte perfect. We are leveraging the Bluetooth stack to make that happen. And here we are getting to the end of it. 5 chapters is not a lot of data, but it is a demonstration of how you can send data in both directions. For this demonstration, I'd like to show how to do point-to-point communication or communication between 2 paired BlueSMiRFs. This might be between sensor networks or other things. Step 1 is to get the first unit into discoverable mode. So we're going to hold the pair button until we see the LEDs blink back and forth. And for the second unit, I'm going to connect it to an additional USB to serial bridge. In this case, I'm crossing over TX and RX because it can't directly plug. It's not designed to directly plug into these USB to serial converter ICs. On this second unit, I'm going to hold the pair button down until we go into discover mode. Okay. Then it is going to seek out other devices also in discoverable mode, and you can see that we've got a status LED that's solid, and we've got a connection between the 2 modules. Now that we've got the 2 units paired and connected, let's go over to the desktop, and we've got this first unit connected to COM3, we've got the second unit connected to COM6, and we can transfer good night, moon, and hello world between the units. For this demo, we're going to show how BlueSMiRF can be used in conjunction with a high-precision GNSS receiver. In this case, it's the UM980. We've designed the what used to be called the FTDI connector, but now it's pretty ubiquitous. It's this sort of serial connection to many different boards. In this case, it's TX, RX, power, and ground. On the back of this board, you can see that we've got the BlueSMiRF plugged in. Right now, on my cell phone, I've got this particular BlueSMiRF paired with my cell phone so that we can go into the serial terminal window and connect to that BlueSMiRF. And in this case, we can see NEMA strings coming by. Pretty nice to be able to get data from a GNSS receiver over to a phone or a laptop or a tablet to do GIS stuff. In this particular case, what we're going to demonstrate today is the use of SW maps. So for those of you that have been following the SparkFun RTK products, I've been doing a lot of precision work. SW maps is my application of choice for getting sort of that NEMA data, but also providing corrections from a base station out to that high precision GNSS device so that it can get something called RTK fix. If that's a lot of TLA gobbledygook, please view some of our other videos regarding GNSS RTK. In this case, we are going to connect to that BlueSMiRF connected to the UM980, and we are going to see a fix. So in particular, this is the back of our building where the antenna is located. We can go and we can look at the current horizontal error, something like 2.5 meters, which is pretty standard for a GNSS receiver. Right now, we're going to leverage BlueSMiRF by taking the fact that we have a Bluetooth connection. We can both receive those NEMA senses, but we can also send corrections back down to that receiver. So in this case, we're going to connect to the base station up on the roof. We're going to hit the connect button. That's going to bring in corrections through my phone over the Bluetooth connection, send it down to the BlueSMiRF. The BlueSMiRF is going to give that to the UM980, and you can see that the RTK LED on the UM980 is illuminated. We've got RTK fix, and now we can go check our GNSS status, and our current horizontal positional error is in the neighborhood of 9 to 14 millimeters. So we've got RTK fix using the BlueSMiRF to send corrections from a device over Bluetooth. The range on the BlueSMiRF is pretty impressive. It's about 100 feet or 33 meters indoors in the SparkFun environment. There's a lot of metal and concrete, and we're able to walk over 100 feet away just transmitting using these really small PCB antennas. It's pretty impressive, the range that we get. Idle current is about 75 milliamps with an active current of 140 milliamps. One of the interesting settings inside the BlueSMiRF firmware is the fact that it has a spot for your Wi-Fi SSID and password. Thanks to the core being the ESP32, we can do over-the-air updates to update the firmware on your BlueSMiRF using Wi-Fi. Whether you're using BlueSMiRF in a breadboard or with one of the boards that we have today with a BlueSMiRF connector, I believe that BlueSMiRF is one of the easiest ways to get up and running with serial connectivity today. Longitudinal should I hold these? Should I just sort of lean behind them? Now, if we jump to I'm gonna have to pause. Got it right that, hey, it even recorded. So yeah, let's use that one.